Hi everybody, welcome to week 2, and I hope you had a good first week. And for this week's lecture video, it's nothing too intense. I just want to give you a big overview of why we're going to be doing what we're doing. And this connects to chapter 0, which you hopefully either had a chance to read or will get to read at some point. It's not particularly difficult. It's just a lot of big picture stuff to set up where we're going to go. So everything else about what's due, what you need to do, concepts, all that should be in our little listing of what you need to do and the challenge sheet and the activity. So definitely, obviously, take a look at all those things. So for this, I just want to hit some big ideas and hit on what I think is the most important part of chapter 0 and what you need to go forward. So let's dive right into that, and let's ask again why we're here. And I like to start with this question of why do we do statistics? And I encourage you to pause this video for 30 seconds and just jot down 1 or 2 things for what comes to mind for why we need to do statistics in the first place. I have 2 answers, but I encourage you to just pause and think about it for a moment. So the reason we do statistics is that there's something we care about, obviously, that we want to analyze. But the reason we do statistics is because there's this thing called variation. All this means is that one observational unit we care about is different than another observational unit. If every single person who took a test had the exact same test score, there's no variation. There really isn't much to describe. Everyone got the same test score, and that's it. So the big reason we do statistics is because there are differences between people. There are differences between cars if we want to model, say, car prices. There are differences between all the little things in our universe, and we want to try to explain that. So that's the first part of this. But the other big part is that, I'll just write it first. The other big part is that we don't have access to our population. Now, if you remember from the review on the challenge sheet in my answers, the population is just everything we care about, every possible individual in the thing that we care about. So the population of Minnesota, all kids in a particular country, all cars from a certain car brand. So the problem is that when we want to talk about something, we don't necessarily have access to the population because it's impractical, or it may be very expensive. It just may be impossible to talk to every single person and interview every single person, which is why we do statistics. This is why we have to take a sample and use the sample to talk about the population. So again, variation and the fact that we don't have the ability to talk to everybody that we want to is exactly why we do statistics. Okay, so that's the first big question. Now, I'm going to erase this. So while I'm erasing this, think about, why do we model things? Why do we make models for things? So why model? things. So we model things because we want to know why things vary. We want to know the things we care about. Because we know that things vary, we want to know why this is the case. We want to know why this is true. Why is one student's test score different from another student's test score? Why does one drug work better than another drug? We want to explain the things we care about. Yeah, we can observe the average price of a car. We can observe someone's heart rate. We can take the average height in a population of people or a sample of people. But we want to know why that's the case. We want to explain these things. And this is what modeling helps us do. We don't necessarily know that what goes into explaining a certain idea or explaining why things are the way they are. So this is why we start with models, to help us explain things. I know it's a really simple idea and I keep reiterating it, but as we go along in this course, and if you start to get lost in the terminology or the techniques or asking why are we doing this, you always come back to this. We want to explain the things we care about. That's really all there is to it. So this is really important because it implies that we have at least two variables or two quantities or two categories or something, two of something that we need to account for. And we'll do this over here. One of those things is what we call the response variable. And this is the thing that we are seeking to explain. This is the thing we care about to explain. So it could be the death rate as a result of consuming some poison, or it could be the average weight of a certain group of people. It's just the thing that we want to care about and the thing that we want to explain for some reason. So in order to explain a response variable, we need an explanatory variable. And it's in the name. An explanatory variable explains a response variable. So, for example, if we pick a response variable of life expectancy, we could pick variables that explain life expectancy, such as weight, diet, things about genetics. We can find ways to quantify those things, or look for categories of things, such as someone who exercises a little, a moderate amount, or a lot, and make that a variable. So really, all of modeling is just this, everything, all of regression, all of ANOVA, all of that. It's just this. We say, I care about something. I know that the units in my population are not all the same. So for the thing I care about, I need to find out why these things vary. And so I'm going to try to find explanatory variables and put those in a model to test how they explain my response variable. And that's really it in terms of the big idea. That's how this works. So there's one other sort of really big idea going into modeling, and let me clear this out. And while I'm doing that, just take a moment and think, what is the main mechanism by which models work? So what is a model actually doing when it tries to represent reality? So think about that for just a second. So what is a model doing? Ultimately, it's purely simplifying reality. That's all a model is. The universe is complex. The things we care about and why they change and vary are complex. So a model simplifies that reality so that we can make an attempt to explain what's going on. That's really, again, the thing we'll be doing in this course is just taking complex things and simplifying them to explain them. So there's a big philosophical assumption here that I'd like you to keep in mind throughout the whole course. And it's pretty straightforward. If we're simplifying reality, what we're saying is that out there in the universe, there is some truth. There's some truth out in the universe for why test scores on children vary in a particular classroom. There's some truth out in the universe for explaining why people's health changes. So we start with the assumption that there is a truth out there, but because the universe is complicated, because we don't have all the available information, we don't just know enough, we start with models to simplify this complexity, and we see how well our model does at explaining reality. That's the whole philosophical approach to what we're doing. And to most, if not all of you, this may not seem very profound. This may seem very simple, and you may be asking, why is he going on and on about this? It's because when people do statistics, they often totally forget that this is what they're doing, that this is why they did this in the first place. Because we make the assumption that there's some truth out there that we don't know, and so we need to make a model to explain it. Last point in this video is that, yes, we are going to simplify reality. So what that means is that, well, we're going to be approximating things. So if we're going to be approximating reality, that means that there's going to be error in what we're doing. And this is where the famous quote by George Box comes into play that all models are wrong, but some are useful. Because all models are a simplification of the universe and reality, they're all going to be wrong. It's really, really difficult to come up with a practical model that makes sense, that gets reality just right. So there's always going to be some error. And that error could be attributed to all kinds of things. Individual differences that are really impossible to quantify is one source of error. There are just sometimes differences between things that we just cannot explain. They just remain unexplained. Another case is people tend to talk about randomness in the universe. And a lot of things are just chalked up to this idea of that there's randomness in the universe that we may not ever be able to explain. And that will just sit there as error. So error is inherent in all the things that we're doing here. And that really is the biggest part of this. So I'm going to pause this, and we'll pick up in the next video on this idea of error, and I'll just briefly hit on sort of the 4-step procedure shown in Chapter 0. All right. Thank you.